Assalamualaikum to Dr. Suhaila. We are from Group 10. My name is Anissa Ashikin binti Jamaluddin and my group's member Muhammad Muzamil Adha bin Mat Rafi, Nur Ipah Marina binti Adnan and Nurul Afiqah binti Asmadi. Today we will present our title, which is Maglev. I will start with the introduction. Maglev is a new mode of transportation that lift and propel vehicles or train using very powerful magnets. The world's first purely maglev system, which provide origin with transit service to the public, was opened in May 1984. It was a low-speed shuttle that ran from Birmingham International Airport terminal to the nearby railway station. Currently, the most well-known commercial high-speed maglev line is the Shanghai Maglev line, which connects Shanghai Pudong International Airport with the outskirts of central Shanghai. Lastly, maglev trains are not compatible with conventional high-speed rail tracks, and therefore a completely new infrastructure is required. The large initial investment cost for the construction of maglev instruction is a serious impediment to commercial use of maglev technology. That's all from me. Thank you.
Hi, my name is Nurul Afiqah binti Asmadi, entry number 262828. Okay, next we will learn about the types of maglev. The first one is electromagnetic suspension, EMS. EMS uses the attractive magnetic force of a magnet beneath a rail to lift the train up. Okay, the keywords for EMS is attractive. Based on the picture for electromagnetic maglev, we can see in current EMS system, the train levitates above a steel rail, while electromagnets attached to the train are oriented toward the rail from below. The electromagnets use feedback control to maintain a train at a constant distance from a track. The second type of maglev is electrodynamic suspension, EDS. EDS uses a repulsive force between two magnetic fields to push the train away from the rail. Okay, the keyword for EDS is repulsive. Based on the picture for electrodynamic maglev, we can see in EDS, both the rail and the train exert a magnetic field, and the train is levitated by the repulsive force between these magnetic fields. The magnetic field in the train is produced by the superconducting electromagnets or by an array of permanent magnets. The repulsive force in the track is created by an induced magnetic field in wires or other conducting strips on the track. The train must have wheels, for example, landing wheel, or some other form of landing gear to support the train until it reaches a speed that can sustain levitation. For example, it can be used when at slow speeds, the current induced in these coils and the resultant magnetic flux is not large enough to support the weight of the train. That's all from me. Thank you. I will pass to the next presenter.
Hello, I will talk about maglev operation. A maglev is magnetic levitation and the idea of using superconducting magnet to levitate a train car. A maglev train uses a physical force of magnetism and electromagnetism to push and pull the car forward. A magnetism is one of the force that engineers use to design and build a maglev trains. The magnet have both north and south poles, so each pole will attract or push them according to the principle. Next is the electromagnet produce a force called electromagnetism, and this magnetism will produce a magnetic force which is temporary and can be switched off and on depending on the operation. On a levitated train, the force of friction is greatly reduced and making the ride faster and smoother. A maglev train do not have a steel wheel and do not run on a steel track. Instead, they operate on a guideway. The powerful electromagnets are used to keep the train on the center of the guideway, and the electromagnet along the guideway and the side of the train will push and pull the train forward. A maglev train afloat on a cushion of air will eliminate the friction, and this allow the train to reach upon 500 km per hour speed. So this is a diagram of a magnet levitation. Along the guideway, we can see a magnetic coils induced in the guideway, and this will levitate a train. So the levitation system have three, which is electrodynamic, electromagnetic, endotrack, and each of the levitation system have their own advantages and disadvantages. That's all from me. Thank you.
Assalamualaikum. My name is Narifah Amanina binti Adnan, matric number 261357. I will talk about the advantage and disadvantage of MATLAB. First is about advantage. The implementation of MATLAB can reduce maintenance costs because this movement does not involve any wheels, so worn wheels do not happen. Next, loud noises throughout the movement of train can be reduced because the MATLAB does not involve the movement of wheels on the track. Disadvantage of MATLAB. First is about cost. MATLAB is a different train system from existing train, so its implementation will involve high cost due to the need to change new infrastructure. Next, energy consumption. Maglev are considered less efficient because large trains have difficulty levitate, so they require more energy.
For the conclusion, Maglev has the potential to become a major mode of transportation. Maglev trains are the fastest mode of ground transportation and can be more efficient than cars and conventional trains at high speeds. The Shanghai Maglev line proved that a commercial high-speed Maglev transportation is reality. However, due to lack of new infrastructure and incompatibility with existing infrastructure, large initial investment capital is required for a commercial use of maglev vehicles. Therefore, the future of maglev transportation is still uncertain. That's all from us. Thank you.